This is the first part of the energy lesson. When I have a box on the ground, and I exert force on this box, this force moved him a certain distance. So I can say that I exert work into this box, so the work is done. The W of the word work, and it is force. Multiply by the distance, but what is the unit of work? The unit of force is Newton, and the unit of distance is meter. Newton times meter gives you a new unit called joule. This is the unit of work. We can conclude this unit in another way. We know that the force, it is mass times acceleration. I will take this and replace it with here. I will say that the work, mass times acceleration, multiplied by distance by unit mass kilogram, unit of acceleration meter, on the second square, and here is meter. Here the exponent is 1, and here the exponent is 1. During the multiplication, we will sum the exponents. Then we will say that the work equals kilogram times meter squared per second squared, and all this will also give me a joule. Now this law, in case F, the force was a constant force. For example, if the force is this, 2 Newton, along this distance is a constant force, but I can push the box a long distance. Then I reduce the force of the push because I'm tired, for example. So the energy that I'm transferring to the box, it has changed. So I can also say that the work, it is the change in energy. This is if the force exerted on the box, not a constant force. Since the unit of work is joule, this is an equation. The right side must equal the left side. So here is joule. The unit of energy must be joule, by the way. Delta means change. If we want to define energy, we will say that the energy, it is the ability to do work, and this is clear from this law. There is something you need to know, that energy is not just one form, but it has more than one form, and it can be transferred from one object to another. Like in this example, transfer from me, I am the one who pushed the box, to the box and move it a certain distance. Suppose there is a car. It is moving at a certain speed, and since it is moving, you will have a certain energy, this energy. What the moving object has, we call it kinetic energy. Kinetic energy. So this car, since it is moving, it has energy. And this energy, we call it kinetic energy. And suppose a pedestrian suddenly come on the car's road and became in front of the car. An accident will happen. This car will hit this person and throw him somewhere far away. Energy transferred from this car, from this moving object to this person, which causes him to be harmed. Suppose this driver stopped due to the shock. The question is, after the driver stops, does he have kinetic energy? Since this body has stopped, its kinetic energy is 0. It has no kinetic energy. We conclude from this that anything standing or not moving it has no kinetic energy. This person was thrown away because the work is now done by the car on the person. We said before that the work, it is the change in energy. Kinetic energy is a form of energy, so I can replace this. I say that the work, it is also the change. In kinetic energy, the speed of the car also affects the accident. Speed is the result of doing work on a certain part of this universe, such as this person hit by the car, which made him fly away. Kinetic energy. Directly proportional with speed, but with speed squared. What happens if the driver moves faster? Sure, it will have a greater kinetic energy because the proportionality between kinetic energy, speed is directly proportional. But if he collides with this person, he will be more harmed than the first case that we explained. Why? Because the speed increased and therefore the kinetic energy increased. So, This huge energy will transfer from the car to this person and get more damage than before. This much energy may not be tolerated by a person, so caused his death, instead of damage as in the first case. But there are a note I want to say. When a car hits a person, it will slow down, because it loses some energy. Where did this part of the energy go? It went to this hit person, which is the victim. But does mass have anything to do with kinetic energy? If we bring a truck, and this truck hit this person, it will definitely be damaged more than a small car. Kinetic energy. Also proportional with mass. Now let's deduce the law of kinetic energy. We said before that kinetic energy is also proportional to the square of the speed, so we put these two together. We will say that kinetic energy is proportional to both mass and kinetic energy. And the square of the speed, if we want to remove the proportion sign and put equals, we must put a constant. So the kinetic energy is equal this constant, which I don't know now, multiplied by the mass, multiplied by the speed scored. Scientists knew that this constant equal to half. So the kinetic energy is half the mass multiplied by speed squared. So the kinetic energy is half the mass, the object moving by the square of the speed at which it moves. If you want to put it in a triangle, we will put kinetic energy above and down half of the mass. Multiply by speed squared. You can switch between two because multiplication is a commutative operation, and you can put the half with the mass or with the speed squared. It will not make a difference because, as I said, multiplication is a commutative process. Let's take this example. A particle with a mass of 0.6 and moving at a speed of 3 meters per second. What is its kinetic energy? First, let's write the data. The mass, it is 0.6 kilograms. And speed, 3 meters per second. And since the object is moving, we will use the law of kinetic energy. So the half of mass by the speed squared. So the half of the mass, 0.6 kilograms, and speed, 3 meters per second. And don't forget to square. This will give me the answer 5.4. Since it is energy, we will say joule. If you want to make this law in a triangle, for the people who like triangles, the KE is up, 1, and the V squared is down. We want the KE, so we will shade this. We will say that kinetic energy equals half the mass by the square of the speed at which it moves. If we go back to the example, the car and the victim when the car stopped. After the accident, do you have any kind of energy other than kinetic energy? We said that kinetic energy, it will be 0 when the moving object is stationary, but does it have any other type of energy? If the driver is disrespectful, he will continue on his way and move on. After the accident, the question is, where did he get this energy from? You will definitely tell me from gasoline. So the gasoline, it has a certain type of energy called potential energy, is the energy that gasoline has, because it has the potential and ability to transform into another energy. In this case, kinetic energy, because the object will move. We call it potential energy or stored energy, and potential energy is symbolized by the symbol PE. From the word potential energy, there are types of these that we will discuss later. So, when the object is stationary, the car has no kinetic energy. If it has gasoline, this means that it has potential energy or stored energy. This energy has the ability to be transformed into other energy, such as, in this case, if it moves again, it will turn into kinetic energy. What are the forms of potential energy? The first form, like the example we just saw, chemical potential energy. Such as those stored in fuel and also those stored in food. We also have potential energy called gravitational potential energy, because gravity is involved. We have energy Stored in the nuclei of atoms is called nuclear energy. This is used in making explosives or making nuclear reactors. We have energy. Stored in the spring is called elastic potential energy. These are the forms of potential energy. Kinetic energy. There are also forms of it, such as light energy. Because if light moves, it will have energy. And thermal energy. If you heat the water, for example, its molecules move, so it also has energy and mechanical energy. Like the example we saw in the case of the car and the victim. In some types of energy, it may be potential energy or kinetic energy, like sound energy or electrical energy. So we can consider it potential energy or kinetic energy, depending on the example. Who comes in it? Let's suppose there is a person. Because he studied physics so much, he decided to commit suicide by throwing himself off the roof. He went up to the top of the house to throw himself down. He went up to use it. The fact that gravity pulls objects downwards, the suicide victim will stand on the roof of a 2-story house, for example. If I ask you a question, does it have kinetic energy? Because he is standing and not moving. On top of the house, it has no kinetic energy. But there are another type of an energy stored in his body as a result of being high above the ground, and the effect of gravity on it. This energy can be converted into other energy. So its name is potential energy, and because gravity is involved, its name is gravitational potential energy, because it is higher than the surface of the Earth. This energy is latent in the body of the elevated person. And this gravitational potential energy is as great as possible. When this victim is at maximum height, so, in this case, at maximum, now is this suicidal person. If he drop himself from up, this potential energy will be converted into kinetic energy. Notice that this person, he is heading down. The height is decreasing, and therefore the potential energy is decreasing. At the same time, its speed is increasing, therefore its kinetic energy is increasing. It is as if the energy is being transferred from potential energy, and it turns into kinetic energy. This is what is meant by the potential energy. It is the energy that can be transformed into something else. So in this case, the potential energy is decreasing, but the kinetic energy is increasing. When is the kinetic energy the greatest possible? Let's assume that here is the surface of the Earth. Kinetic energy is as high as possible, just before it hits the ground. Why? Because it will have the highest speed. When is potential energy at its lowest? Which in this case is gravitational potential energy, at minimum. Also, just before it hits the ground. Why? Because there will be no height. Now let's suppose that he is hit the ground. What is the state of potential energy and kinetic energy? Because the body did not move after it hit the ground. So the kinetic energy equals 0, and there is no rise. Gravitational potential energy also equals 0. Therefore, potential energy became 0, because gravity cannot pull the body further downwards. Also because the height of this body above the surface of the Earth is equal to 0. So there is no height. Therefore, gravity cannot affect it. We conclude that gravitational potential energy, also called weight potential energy. The first thing it depends on body weight. And weight is a force, and we symbolize it with the symbol W. Some people symbolize it with the symbol FW. But this W is different from the work, which is from the word weight. Weight is mass times gravity. The second thing that potential energy depends on is gravitational potential energy, which is height. So let's not forget, this height is also affects gravitational potential energy. Delta H We did not put h because the height of the object is relative to something else. This other thing, we call it the reference level in this case. The ground surface. What is the reference level? Reference level at which gravitational potential energy is equals 0. Now let's try to deduce the law. We said before that the work, it is the product of the force multiplied by the distance. And we also said that work equals the change in energy. And we said that the force, mass multiplied by acceleration. But since here the force is the force of weight and motion on the y-axis, we will replace the acceleration with the acceleration due to gravity. So let's put Fi here. So let's substitute it and say that the work equals mg. We replace d with the h, so we will put h, but we will put delta before it. Because we said in the case of gravitational potential energy, we take into consideration two things. Something for something else, which is the reference level. Now I said the work is equal. Change in energy in gravitational potential energy is also energy. I can say the change in gravitational potential energy is equal to mg delta h. So, save this law. Now I can play with this law also. Since mg is the weight force, but I can put multiply by delta h. Some may ask why we put delta h. To take into account the position of the object relative to the reference level. What would happen if this victim, he threw himself from a 3-story building? The first thing we notice is that height increased from the surface of the Earth, which in this case is the reference level. Delta H becomes large if gravitational potential energy when the victim is up as highest as possible. It also increased compared to the first case. Because this body is at rest, the kinetic energy equals to 0. This person, if he dropped himself from up, potential energy would be converted into kinetic energy because it was bigger than before. The speed will be greater than before. It will fall faster than before. When it hits the ground, it will be damaged more than before, and the kinetic energy will be greater than possible. Just before it hits the ground, potential energy is as low as possible. Just before it hits the ground, because there is no height, because gravity cannot pull the body any further than before. But if it hits the ground, it is at rest, and therefore, kinetic energy is 0 and there is no height. Gravitational potential energy is also equal to 0. By the way, we put the letter G under the symbol PE because it comes from the word gravity. Gravity means attraction. We notice that the gravitational potential energy is always related to two interacting objects, one relative to another. Take this example. Ali lifted weights from the ground to above his head. Ali was 2 meters tall. The mass of the lifted body is 5 kilograms. Calculate the energy possessed by the lifted object. What is its type? First, let's write the data. The mass, 5 kilograms. The height, 2 meters. He wants type of energy and its value. Let me draw it. This is the surface of the Earth. This is Ali. And Ali? Heavy lifting. The mass of this weight is 5 kilograms. Ali's height, 2 meters. Now, if he leaves the weight, what would happen to them? It will surely fall to the ground. This type of energy is potential energy because it can be transformed into another energy, which is kinetic energy, and it is gravitational potential energy. Because gravity is what affects the object and pulled it down, this is gravitational potential energy. Now, if you want to put this law in a triangle, we will put the gravitational potential energy up and down, mass times gravity times height. Note that the reference level is the ground surface, Because the gravitational potential energy on the Earth's surface is equal to 0. We said before that any delta means the final minus the initial. The final height is here, which is 2 meters. As for the initial, which is at the reference level, which is 0, let's put the law. He wants potential energy. We will say that potential energy is the product of mass by acceleration due to gravity. By changing the height, 5 kilograms, multiply by the gravity, remember at 10 meter per second squared, multiply by minus h initial, the final minus initial. Let's substitute. 5 kilograms, same as it is. 10 meters. On the second square, same it is, the final one, which is 2 meters minus the initial, which is 0. Put all of this on the calculator, of course. Here, the unit is a meter. He will give you 100, because this is energy, we call it joules. Now, if he wants kilojoules, what should we do? We know that a kilo is equal to 1,000, so I can convert from kilojoules. Go to Joule, remove the K, and replace it with 1,000. And we will multiply, because if you hit something big, you hit it. Hit him, and he turns into something small. And if the opposite, I will divide by 1,000. So if we want to convert from joules to kilojoules, I will divide by 1,000. I will say divide by 1,000. This will give me 0.1 kilojoules.